All right, everybody say hi to the people on vacation.
Hi guys, you've been missed.
Or don't say hi. All right, so this little video we're actually doing in front of the class today. So those of you that are watching the video, there's kids here. So if you hear people talking, that's cool. And I might be asking them questions and stuff. So one thing that we didn't talk about yet is evaluating inverse trig functions. So we talked about using arc sine, arc cosine to cancel sine and cosine, right, to solve an equation. But actually using them on for the unit circle is something that you'll need to be able to do. And this is really basic, okay? So you know how normally we would say, if they ask what's the sine of 30 degrees, we would just look at the y-coordinate, right, and say it's 1/2, right? Well, this is just going the opposite. So arc sine and arc cosine is essentially asking, you know, so it's like arc cosine right here. This is essentially asking the cosine of what angle is the square root of 2/2. All right, does that make sense? So instead of asking or instead of giving the angle and wanting to know the value of it, they give you the value and want you to tell me what's the angle. So the answer is going to be an angle. All right. So all I've got to do is say, all right, for arc cosine of the square root of 2/2, I'm going to go to my unit circle and look for the square root of 2/2 in which coordinate? What's cosine is what? Cosine's x, right? So I'm going to find square root of 2/2 on the x coordinates. And whatever angle that is, that's my answer. Okay, so right here we can see square root of 2/2. Okay, there are multiple angles. Good question. So John asks, are there not multiple angles? There are. So you can see square root of 2/2 right here, and also square root of 2/2 down here. So it's like, well, which one do we use? Okay, so here's the rule. For cosine, you use the angles up at the top. Okay, so anything between 0 and pi, or 0 and 180, that's the ones you use if it's arc cosine. All right, everybody hear that? So arc cosine, you use the angles up here. If it's arc sine or arc tangent, you use the ones on the right side. Okay, so anything from down here at negative pi/2 up to positive pi/2. Okay, does that make sense? All right, so yeah, cosines from 0 to pi, and arc sine and arc tangent, you'd use negative pi/2 to positive pi/2 for your angles. So we're not going to use 11 pi/6, 7 pi/4, 5 pi/3. We're going to pretend that these are negative angles when we use sine and arc sine and arc tangent. All right, so let's do this right here real quick. Cosine, arc cosine of square root of 2/2. So cosine is the x coordinate. So find the x coordinate up here that is the square root of 2/2. So if we look at the x coordinates, we got square root of 3/2, square root of 2/2, 1/2, 0, 1/2, negative square root of 2/2, and negative square root of 3/2, and negative 1. So this is the only one right here that is square root of 2/2, right? So then that tells us what our answer is, the angle 45 degrees. Okay, so for that first one, our answer we would just say 45 degrees. Or if they wanted it in radians, you could say pi/4 radians. That make sense? All right, so then for arc sine of 1/2. So now for sine, you're looking at the y values. What?
How do you know if it's arc?
The little -1. These mean the same thing. If it says arc sine, that's the same thing as this, sine -1. Okay? Arc cosine, this right here, is the same thing as this. The little -1 means arc, basically. Okay? So if I want to do arc sine of -1/2, sine of the y values, right? So I'm going to look at the y values, but for y, or for sine, you look at the y values on this right side, right? Remember, cosine's the top ones, sine and tangent, you use the two on the right. So I'm going to look for 1/2, or -1/2 over here on the y values. So where do you see -1/2?
At the bottom.
Right here, right? So -1/2 on this one. So arc sine of -1/2, we're going to say is, you wouldn't say 11 pi/6, use a negative angle. If I go down, I went down pi/6, right? So the answer for that one will be negative pi/6. Make sense? If you want it as a degree, it would be negative 30 degrees. Okay, or negative 30 degrees. Okay, either one's fine.
Negative 30? Because you
Because you're down 30 degrees.
Okay.
Yeah. Yeah, man.
Using the two right sides.
That's just what you always do for sine or tangent. For sine and tangent, you always use these two quadrants. For cosine, use the top two. And the reason why is because you've got to be able to account for positives and negatives. Well, your sine is y, the y values, right? So over here, you get negatives and positives. Okay, but for cosine, you need negatives and positives. But over here, x, for cosine, they're all positive. So for cosine, we have to use these two quadrants so we get some negatives for cosine. That way, if the value they're asking us for is a negative value, we can use those numbers. Does that make sense?
Yeah.
All right. So arc sine of 2. Well, do you see 2 on any of the y coordinates? No. So this one you can't do. You cannot do arc sine of 2. That's no answer. Okay. Anything more than 1 or less than negative 1 is not possible when you do arc sine and arc cosine or arc tangent. Right, Jordan?
Right.
All right, put the phone away, pay attention.
So, are there going to be too much of on the test?
There could be. All you need to know is it's got to be between 1 and negative 1. Whatever this number is that you're taking the arc sine, arc cosine, arc tangent of, can't be more than 1. It can't be less than negative 1. All right, so arc cosine of negative 1. So we could do this one. Cosine is the x coordinates, and then we're going to check the top two. So where is the x coordinate negative 1? Well, the x coordinate, go around, look around. I don't see negative 1 until I get to here, right? So right there, x is negative 1. So the answer is going to be either pi or 180 degrees, depending on if you're talking about radians or degrees. So we can say it's either pi or it's 180 degrees. Does that make sense?
Yep.
Okay, just remember cosine's the top two, and then sine and tangent are the ones on the right. All right, so let's look at tangent. Arc tangent of 0. Now remember, tangent is what letter? Y over x, right? Not just y, not just x. You got to do y over x. So for tangent, it's a little bit trickier because you might have to divide the y and x coordinates to determine what the value is. So for arc tangent being 0, when does y divided by x give us 0? And remember, for tangent, we're gonna use the two right quadrants. So where do we get 0? So y divided by x, right? 0 divided by 1 is 0, right? So right here is where tangent is 0. At, you could say 0 degrees or 360 degrees or 2 pi radians or 0 pi radians, right? But what we always want to use is the smallest one. So let's use, say 0 degrees. Tangent of 0 degrees. Okay? Don't use 360 and 2 pi. You say why?
You don't want us to use the 360 or 2 pi?
Yeah, use 0. Yeah, because it's always going to be between, for tangent and sine, it's always between negative 90 degrees and positive 90 degrees. Huh?
Otherwise, you get repeated angles.
Yeah, you'd have repeated angles. So it's always between negative 90 and positive 90 for sine and tangent. And it's always between 0 and 180 degrees for cosine. So that's why we wouldn't use 360. All right, so then arc tangent of negative square root of 3 over 3. So we got to figure out which of these coordinates over here, when I do y divided by x, gives me negative square root of 3 over 3. Well, obviously, it's not going to be any of these up here because those are all positive, right? So when I divide a positive by positive, it's not going to give me negative. It's got to be one of the 3 that are down here. Okay, so which one do you think I should? It's obviously not this one right here because that doesn't even have square root of 3s. It has square root of 2s, right? Square root of 2 over 2, square root of 2 over 2. So that's not going to be it. It's got to be one of these two. So you might have to check and see. So you know how we divide fractions? Keep change flip. Good. So if I try this one, y divided by x, negative 1/2 divided by square root of 3 over 2. So that's going to be times 2 over square root of 3, right? So then that's going to give me negative 2 over 2 square root of 3.
Could you just cancel out the 2's and then put 1 over square root of 3?
Yep.
Okay.
So that's going to be negative 1 over square root of 3.
That's square root on the bottom.
And then what do you do with the square root on the bottom?
You add a 3 on the top.
And then just leave it a 3, right? So does that one give me what I need?
Yes.
Yes. So I'm going to use that angle. And remember, we don't use, say, 330 degrees. It's got to be what?
30. You got the money.
Negative 30, right? Because we go down. So we pretend that we start here and go down to get there. So it's negative 30 degrees. Or you could say negative pi over 6. Does that make sense? Can I see how that works? Okay, if you go down to this quadrant, it's got to be a negative angle. anything up to these for cosine or sine or tangent, it'll be a positive. But whenever you go down to this one, use a negative t-squared. Y'all feel like you can do the inverse trig functions
You wrote
now?
down the wrong one.
Oh, my bad. Skadoosh. Thanks, Alexis. And then the other one's 0, right? Okay, the other thing I need to show you, there's one other thing. Whoops. Okay, is how to use Pythagorean theorem sometimes to evaluate trig functions. Okay, so what's this right here? So if I tell you cosine is -2/5 and sine is just a positive. All I know is sine is positive and cosine is -2/5. And I want to find all the trig functions of theta. So secant, cosecant, tangent, cotangent, I want to find all of them. So what we're going to do is draw a triangle. All right, remember cosine is what over what?
Adjacent over hypotenuse.
Adjacent over hypotenuse. So this is the adjacent, and this is the hypotenuse, right? If there's a negative, you always put it on the side that's adjacent or opposite. Don't put it on the hypotenuse. Okay. So we're going to say we've got, let's see, here's our x-axis, and we're going to go to, if the top number is the adjacent side, we're going to draw a triangle. Cosine is x, so we're going to go out to this direction, right? 1, 2. So that's -2, right? Because cosine is the x-coordinate. And then 5 is the hypotenuse. So we're going to draw our hypotenuse out here somewhere at 5. And we want to figure out what's that third side using the Pythagorean theorem. Remember how to use the Pythagorean theorem?
A squared plus B squared equals C squared.
Yep. Okay, so what's C? C is 5. And then we can make -2 either A or B. It doesn't matter. So that's 4 squared, or that's 4 plus B squared equals 5 squared, 25.
21.
And then we subtract 4, so B squared is going to equal 21. So then B has to be square root of 21. So the length of this side is square root of 21. That's the y coordinate, right? That would be the y value on your graph. So that will tell us how that we can use that now to find sine, tangent, cotangent, whatever we want, right? So sine,
Could you draw the theta?
right there would be your theta, right? Yeah, so sine, remember, because theta, cosine is adjacent over hypotenuse, right? So there's your adjacent, there's your hypotenuse. So sine of theta then is going to be opposite over hypotenuse. Square root of 21 over 5. Tangent is going to be opposite over what?
What?
Tangent's what? TOA, right?
Opposite over adjacent.
Opposite over adjacent, so opposite's square root of 21, and adjacent's -2. Okay, so y'all see how I figure those out? You just got to find that third value, then you can use your triangle to find the other trig functions. I already know cosine, so to find cosecant, I got to flip what? What do I flip to get cosecant? I flip sine.
1 over y.
Yeah, so it's flip sine upside down. So that's 5 over square root of 21, and then I just move the square root to the top, 5 over square root of 21 over 21. And of course, if 5 and 21 would reduce, like a fraction, you'd reduce them, but 5 over 21 won't reduce. Then secant, I'm just going to flip what? What do you?
1 over x.
Yeah, that's cosine, right? So I was going to flip this, -5 over 2.
How did you find tangent?
Tangent, I did opposite square root of 21 over adjacent -2. Make sense? Yeah, it's square root of 21. And then to find cotangent, you just flip tangent. So I flip tangent, make it -2 over square root of 21. And then I've got to move the square root to the top, so it's -2 square root of 21 over 21. And the 21 won't reduce with 2, so that's your cotangent. So there's all the other ones. I already knew cosine. There's the other 5.
Are there arc secants?
There are arc secants and cosecants. You don't use those a whole lot, but yeah, those are. We're not going to get into them much here. All right, do you want to see another one of those?
Yeah.
Okay, so I know sine theta. So sine is your y coordinate, right? Or your opposite. And 3 is you can think of it as the radius and the hypotenuse. So if I draw my graph, the y value is -2. So if I go down 2, right, -2 would be down 2, and then I go out to the out somewhere. Here's my hypotenuse is 3, right? So I went down -2, and then I go right here's 3. I need to figure out what's that x coordinate, right? Does that make sense? Wait, sorry, hold on.
Yeah, could you do that in another color?
The blue doesn't work good?
No, I'm saying draw your little graph and then do the.
Oh, do the line and I got you. Alright, so hypotenuse is 3, and the y value that we've got is -2. Here's my theta. Okay, so -2 is opposite, right? It's opposite theta, and I want to figure out what's the adjacent side right here, or my it's also my x value, right? So Pythagorean theorem, 3 squared is the c, and now I've got -2 squared plus b squared. That's 4 plus b squared equals 9. Subtract 4, so b squared equals 5. So then b's got to be what? Square root of 5. So this other side over here is the square root of 5. So now I can find, it says, this one just says find cosine of theta. Alright? Huh? Say what? John, do you have a question? Okay, I forgot to mention that this part's important, that sine theta is greater than 0. That tells me which quadrant I'm in, because cosine is negative in 2 different quadrants, right? Cosine is negative in this quadrant, right? Remember A smart trig class? Cosine's negative in both of these quadrants. You know what I'm saying? So it's important to know sine's positive. That tells us which one of these to go to, because it's A smart trig class. So that's the only quadrant that cosine is negative in and sine is positive. Does that make sense? So that's how we know that's where we need to draw a triangle. In this one, we know that tangent, so I do this in the wrong quadrant. Right here, we're told that tangent's positive. So which quadrant is sine negative and tangent positive?
The bottom.
The bottom one, right? Because up here, tangent's positive, but sine's positive up there. So I got to draw my triangle over here. I drew it wrong to start with. So the sine value is going to come down -2, and then it's going to go out this way 3. Okay, and the reason that's important is because you know whether your x is going to be positive or negative. Over here, x would be positive square root of 5, but since I'm drawing it over here, x has to be negative square root of 5. Does that make sense? Okay, so it's important to know which quadrant you're in so you know whether that value is positive or negative. Because you remember how you take a square root and it's always plus or minus? So this is really plus or minus square root of 5. That's how I know whether to use plus square root of 5 or negative square root of 5 is based off what quadrant it goes into. So I'm going to use negative square root of 5 for cosine. So when I write cosine theta is going to be the adjacent side, which was, or sorry, I should have drawn my triangle this way. Is negative square root of 5 over 3. Okay, it's negative square root of 5 because I know I'm in that quadrant down there where cosine is negative. Does that make sense? Okay, so you got to pay attention with the quadrant to know whether you're going to use positive or negative when you take the square root on the Pythagorean theorem.
How'd you get the cosine?
Cosine is the x coordinate. The x coordinate right here is negative square root of 5 to get out here, right? So it's the x coordinate over the hypotenuse. Make sense? Alright, up here it was sine's positive, cosine's negative. That's this quadrant, A smart. So sine's positive here, but cosine's negative. So I had to go -2, and then of course that y value is going to be positive. So it's going to be positive square root of 21, not negative square root of 21.
So what does that sign have to do with? You see what it says?
Yeah, that tells me which quadrant I'm in. Because if sine's positive, but cosine is negative, then I've got to be in this quadrant. There's only 2 quadrants sine's positive in. The one where everything's positive, and this one, right? A smart trig class. So S right here tells me this quadrant sine's positive, but that's the one where cosine's negative. So I know I'm in this quadrant. So what that tells me is that whenever I solve and do Pythagorean theorem, when I take the square root, now you got to put plus minus in front of the square root. It tells me that if I'm in this quadrant, whether to use positive or negative. So in this quadrant, the y value is going to be a positive number because I'm going up. If I was down here in this quadrant, then it would be I would use the negative for the square root of 21, which of course is going to change all these numbers that have the square root of 21 and be negative on the square root of 21. Now on this one, I say, oh, tangent's positive, sine's negative, so that's got to be in this quadrant. Tangent's positive right here and sine's negative. All right, y'all see how that works?
Why do you go down first on the 2 and not left?
Because it's sine, and sine is a y value. Right? So it's knowing sine's y value, that -2 is a y number. You know what I'm saying? If that was cosine, then I would go left, -2, like I did on the left there. Just depends on whether you're using y coordinate or x coordinate. All right, so that's the only things that we hadn't really talked about that I wanted to go over that might be on your test tomorrow. Keith, you awake with it? You with us? All right, today we'll do something a little different.